general antiderivative for 1 over 2x squared plus 2x. Now this is going to use a technique from algebra called partial fraction decomposition. So as a first step, let's simplify our integral. So we have integral dx over, there's a quantity 2x that can be pulled out as a GCF, leaving you with x plus 1. And then because 2 is a constant, I'm going to pull that out completely in front and just consider 1/2 integral dx over x times x plus 1. Okay, now that has a product of these two linear factors in the denominator, and so it might be, and that's relatively difficult to integrate. It's not going to be an obvious u substitution or anything like that. So what we're going to try to do instead is take that product and split this into two separate rational expressions that are being added together. And that's partial fraction decomposition. So effectively what we wish is that I can take 1 over x times x plus 1, and I'm kind of hoping that I can write this as some number over x plus some other number over x plus 1. Because both of the two objects on the right would just be simple logarithm antiderivatives, right? Okay, so to that end, let's take this and multiply through by x times x plus 1 to clear our denominators nicely. So when we do so in the first step, the x and the x plus 1 reduce, 1 is left over, equals, next step, the x's cancel but the x plus 1 is left over, so we'll have a times x plus 1. And in the last step, last term, the x plus 1's reduce, leaving the b. So we have a bx. Now in order to figure out the constants a and b that we need, let's do a little strategic simplification here. We're going to substitute x equals to 0 into our expression, our equation here. So if we replace x with 0 everywhere we see it, we can see that 1 equals a times 0 plus 1 plus b times 0. Right? Now 0 plus 1 is 1, and 1 times a is a, so that's just an a. B times 0 is of course 0, so what are we getting? But 1 equals a. So we actually already know the a constant almost for free when we plugged in x equals 0. So similarly, I'm now going to plug in x equals negative 1. The same kind of sneakiness, because that's going to make this piece right here become very simple. So 1 equals a times negative 1 plus 1 plus b times negative 1. So therefore 1 equals, this of course would be 0, b times negative 1 is negative b, and so final result is that we end up getting b is equal to negative 1. Okay, so what that allows us to do now is take that original integral that we were working with, 1/2 integral, and inside we are now going to be able to split, since we know that a is 1 and b is negative 1. In order to rewrite that expression, the integrand, we're now going to have 1 over x plus a negative 1, so I'll just put minus 1 over x plus 1 dx. And notice that's a whole lot easier to integrate, right? 1/2, an antiderivative of 1 over x would be log x, and an antiderivative of 1 over x plus 1 would be log x plus 1. Of course, plus a constant, because it's a general antiderivative. So there's how you can use partial fraction decomposition in order to find an integral.